Hi, Bill here, Featherweight Guy. About 3 or 4 days ago, I posted a video showing how I prep a featherweight for painting. I had a stripped featherweight in 1936 one that I was showing. And in that video, I explained how the internal shafts, the three main shafts and the gear mesh, can be returned back to they were at the factory. And part of that, I explained, was that the teeth on the gears are marked with a pin mark so you can get them back in the same configuration. Well, I have an update, because since then I was cleaning up. You may recall I'm doing a batch of 6 machines, and so I was going through and cleaning up the gears on the other ones, and I found to my dismay that not all of the gear sets have that mark, which was a kind of a round indent, kind of a pinhole about there on the gears. And here's a set from a 1941 machine, excuse me, that are unmarked. And so that had me wondering if perhaps that what I was assuming was a mark to restore the teeth to their original tooth-to-tooth configuration was actually just some sort of a manufacturing mark that had nothing to do with that. So that got me wondering, and so I want to do a couple of little quick experiments here to prove or disprove how this all might work. So I've got this is a featherweight that's going to need to be stripped and repainted. I started sanding and dealing with some issues here, so ignore that. The first thing I want to do is just show you what the difference is in number of turns of the main shaft versus the number of turns of the hook. So I've got this machine. I'm going to bring it to what we call top dead center, which is right about there. I'm lining up this connecting rod so that it falls directly behind the needle bar. And right there is top dead center. So I'm going to put a piece of tape on the guard and a piece of tape on the hand wheel. And we'll just make a nice mark on there with a Sharpie. Okay, so there's our hand wheel mark. In that position, the top of the hook is right here. In fact, the hook is kind of vertical right now as we're at top dead center. So I'm going to turn the hand wheel. The hook has now completed 1 rotation. And as our mark on top comes back up, we've completed exactly 2. So this is a 2-to-1 ratio. 1 turn of the main shaft is 2 turns of the lower shaft. And, I think many of you may have known that. And that would lead to an assumption that the way the gears work, because it's an even 2-to-1 ratio, that the same teeth would come into the small tooth, the smaller gear would be hitting 2 specific teeth on opposite sides of the larger gear in both situations. But that's actually not the case. And the reason is the number of teeth on these things. I've done the count. The larger gears have 28 teeth. Both of these, one is on the upper shaft and the other is at the bottom of the vertical shaft. And the smaller gears have 18 and 21 teeth. So if you do the math on that, which I've written down here, so on the top shaft, there's a 28-tooth gear that's intersecting an 18-tooth gear. And if you divide that out, what that tells you is that each revolution of the upper shaft is resulting in 1.555 repeating revolutions of the vertical shaft. And then at the bottom of that shaft, we have another 28-tooth gear hitting a 21-tooth gear. And we do the math on that, and that means that every revolution of that vertical shaft is resulting in 1.333 repeating revolutions of the bottom shaft. And if we multiply the 1.555 by the 1.333, we come out with the 2. So that's how the math works on the teeth on the gears here. So what I want to do now is we're going to do a little experiment. I'm going to set these aside. I'm going to turn this over, and I'm going to reset the camera so we can zoom in closely. But I'm going to mark with colored Sharpie the smaller gear, and each time it goes around, we're going to check off a tooth on the larger gear. And what I think we're going to see here is, with enough revolutions, the same tooth on the small gear eventually connects with every tooth on the big gear. And if that is true, then there is no reason to worry about which tooth you align between the gears when you reassemble, because there is no repeating pattern here. It's going to be each tooth eventually contacts every other tooth uniformly. So we're gonna prove or disprove that theory here in just a moment. So I'm going to reset the camera and get you zoomed in here. We'll mark things up and we'll give this a go. Hang on. All right, here we go. So what I'm going to do is I'm going to make a mark here with a Sharpie so that I will know when a particular tooth, it's actually on the opposite side of this gear, so the tooth on the opposite side of this wheel is now in contact with this lower gear, and I'll be able to tell when I come back around, I'll know I'm on the same tooth down below. So now let's make a mark down here, and when I have this mark lined up here, I'm going to make a mark. All right, I hope that shows up. So as I turn the wheel now, I'm going to actually use different color markers here as we go around. So I'm going to I'm turning the hand wheel toward me, same way it is when we sew. And now there's where we are. So I'm going to make a magenta mark. And now I'm going to go around again. And I'm going to make a green mark. And then we'll go around again. And I'm going to make an orange mark. And we'll go around again. And now we find that we're back to the blue mark, which was the first one I made. And we go around again. And we come to the magenta mark, which was the second one I made. And we go around again, and we come to the green mark, which was the third one I made. And we go around again, and we come to the orange mark, which was the fourth one I made. So there is a repeating pattern here. There's 4 revolutions to get through the cycle, and on the 5th revolution, we're back to the start of the cycle, which means that there is a pattern of the teeth here hitting essentially the same 4 teeth on the larger gear. That's how it works down here. There'll be a similar repeating pattern, I'm sure, on the upper gear as well, which now kind of leaves me a little curious, because this second set of gears that I took out of the 1941 machine has no visible marking. So either the fact that one tooth actually repeatedly intersects 4 teeth on the big gear may mean that the mesh, you don't need to worry about it, because it's not a 1-to-1, it's actually a 1-to-4, and there must be enough even wear there. That's one possibility, is don't worry about the mesh. The other possibility is maybe I should have marked, put some sort of a scratch mark on not on the tooth, but on a part of the gear that I could still see even after I've cleaned and polished this, so that I could restore these back to that same mesh later. And I did not do that on this 1941 machine, because I had already taken the 36 apart, and I had seen that pin mark, and I assumed that there was going to be those markings on every one. So I don't have a way now to necessarily get the 1941 machine back to exactly the same teeth. But the fact that one tooth actually repeatedly hits the same 4 has me less worried. All right, it's a couple days later. I had a question about whether or not we need to worry about this tooth-to-tooth gear mesh. And so I sent an email question in to the Featherweight shop on Friday. And I got an immediate reply thanking me for what they said was a great question, but that their tech staff was off and wouldn't get back until today, Monday. I just heard back from the Featherweight shop, and the answer about the gear mesh is that there aren't any alignment marks. you simply reassemble the gears and check to make sure you have proper clearance between the teeth and proper end play. That is, you got a little bit of movement at the ends of the shaft, just a small amount, a couple thousandths is probably plenty, although they didn't give you an amount. They did say if needed, you could use lapping compound and relap the gears. Now, so I think the answer, based on what we determined here, is that there is no need to worry about getting the teeth back into exactly the same tooth-to-tooth configuration. We simply need to get things back on the shafts correctly, make sure that the teeth are engaging without binding and with adequate end play, and everything's going to be fine. If the machine does sound noisy and the gear train doesn't seem right, we can go to get some lapping compound and use an electric drill to power the thing for a while and lap it for a couple hours. Lapping compound, by the way, is a paste. It comes in a tube in different grits. It's basically a paste grit, and what it's doing is you apply it into the gears, and it's basically doing a little bit of grinding and polishing and removing bits of metal so that the gears engage cleanly. So it'll take off any burrs, any high spots. It'll kind of even out the mesh of the teeth. The Singer's gears are really high quality, and when I look at the teeth on these things, I see virtually no indications of wear. I don't know what their metallurgists developed for an alloy for these gears, but it's very strong. So I'm going to assume that in the vast majority of cases, there will not even be a need to relap the gears. So that's great news. I did want to point out a couple of other things. When you do reassemble this lower shaft here, there is a little bit to worry about, because the way everything comes together, you can't put the things on the upper shaft incorrectly, as I described in the earlier video. But on the lower shaft, we have to worry about the hook timing. And so when this goes together, you're going to be installing this gear on the shaft as you come through, and you'll be putting this counterbalance weight. It goes on this lower shaft. There's a line that's in the shaft that this gear will go up against, and then you tighten the set screw on one of the two flats. There are two flats on this shaft, and that will then be in the correct position. That will allow the right amount of shaft and flat to be exposed for the hook to go on. Now, the reason there's a little bit of trickiness is the hook is going to go on the flat as well, but the hook has two set screws, one on this side and the other on this side. So you have two choices about which way to put this on the shaft. But it's actually not that hard once you think about it. This counterbalance, you can see it's got a lot more material on this side of this cam-shaped lobe, and that's going to counterbalance. When you look at the hook, there's a lot more metal on the side opposite the point of the hook. That's the point of the hook right there. And look at all the metal that's on the other side. So that's what we're counterbalancing. So when this goes on the shaft, you're basically going to use the set screw that's on the hook point end and put that on the shaft and tighten that down. All of the timing adjustments are actually made by loosening the gear. You loosen the two set screws. They're 90 degrees opposite each other on that particular gear. You loosen those two and you rotate this whole shaft. And basically, to get this into approximately the right timing, you're going to rotate this upper shaft and get it into top dead center, which I showed you earlier. And when that shaft is in top dead center, this hook is going to be pointing vertically, straight up and down. It's going to be a quarter turn away from reaching the needle. So if you set this shaft in that position with the upper bar at top dead center, you can then tighten these down lightly, and that's going to be fine for initial assembly. And later, you can use the timing marks that are on the needle bar and set the timing correctly. But that'll get it together for you. So I hope that clears up some confusion about the mesh of the gears. It's basically, there is no marking. Those holes that I saw that I assumed were assembly marks are actually not. So I am no longer going to be terribly worried about getting the teeth back to exactly the same ones when I reassemble these things. All right. Thank you very much. Bye.